Okay, everybody, so we're back at it again. So we're going to be looking at sine and cosine values today. So here's the idea. In the previous two lectures, what we looked at was right triangle trigonometry. So we did right triangle trigonometry. But there are two types of trigonometry, right? I told you that. You just had to believe me, right? So there were two types of trig that we had to worry about. There are two types of trig to understand. The first type that we looked at was right triangle trig. And we already did that in the previous two lectures. But just what that was about, of course, you know, was you have a right triangle somewhere in your problem, like so. You have an angle theta. You label your sides as opposite, adjacent, which does not have a G, has a J, opposite, adjacent, and hypotenuse. And then you define your trig functions in terms of that. So like the sine of theta is the length of the opposite side over the length of the hypotenuse. The cosine of theta is the length of the adjacent side over the hypotenuse. The tangent of theta is the opposite side over the adjacent side. And then I'm not going to write them, but there are three more. Okay? And so that is stuff that you've already done. However, there's another type of trigonometry. So the next type of trigonometry is called unit circle trigonometry. And it's not that these are really different. It's more like right triangle trigonometry is like a part of unit circle trigonometry. Okay, but it'll be easier for you if you just think of these as separate things. Trigonometry. All right, so like I said, it will be better for you if you can think of these as separate things and then don't try to mix your formulas, because you're not going to be able to use all these formulas up here when you're doing unit circle trigonometry, really. You kind of just forget them and move on. All right, so unit circle trigonometry. In order to talk about unit circle trigonometry, we need to know what a unit circle is. So the unit circle is a circle, okay, good, with radius 1, centered at 0, 0 on the xy plane. Okay, now some of you guys may be taking more math in the future. Well, probably a lot of you are. Some of you might take a whole lot more math in the future. If you're a mathematician, then you know by the time you're like a junior or senior in college and you've taken a bunch of math classes, you'll realize that actually this word here, unit, that just means one. So when they say the unit circle, they mean the one circle. That's all. So that's what unit means, right? A single, like unit for a single unit. Yeah, so that's what it is. So that's the unit circle. It has an equation, and you need to know the equation because we're going to use it. So the equation of the unit circle is x squared plus y squared equals 1. And honestly, like that equation is half of this section, just knowing that equation. Now let's look at the unit circle. Okay, so I want a set of axes like that, that's x, this will be y. I'll label it down here where it's out of the way. And we need a circle, right? and the circle should be radius 1. So how big should radius 1 be? How about 1, 2, 3, 4, 1, 2, 3, 4, 5. It's about as big as we can make it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so that's going to be 1, minus 1, minus 1, 1. Okay, and we need a circle there. So let's draw a circle. Okay, make it magically good. Let's put it where it goes. Come on, you can do it. Make bigger. Okay. Move down. All right, good enough. Okay, so there we go. That is the unit circle. All right, and again, it has this equation up here, right? This is x squared plus y squared equals 1. So every point on the unit circle satisfies that equation. So like, for example, let me just take a point here from the homework. It's giving me numbers I don't like. So I'm clicking a few times. All right, well, I give up. Give up. Oh no, there we go. So here's a point on the unit circle, right? So if I say, so this is, I'm saying example, but you know, this isn't really an example of anything. But example, 4/5, comma, -3/5 is a point on the unit circle. Why is it a point on the unit circle? Well, if you take these x and y values, right, like you've got an x value right here. Well, come on, undo. You have an x value right here, and you've got a y value right here. And if you take those and you plug those into the unit circle equation, it should be a true equation. And that's how you know that this point is actually on the unit circle, right? So just to check or verify, plug x equals 4/5, y equals -3/5 into x squared plus y squared equals 1. Okay, so we're going to do that right now. Let's try it. So if you put, what was it? 4/5 squared plus -3/5 squared equals 1. And I'm going to put a question mark over this, right? Because I don't know that it equals 1. If it does equal 1, it's a point on the unit circle. But if it doesn't, then it's not a point on the unit circle. So I'm putting a question mark over there to indicate that I do not know if these are actually equal. But we can work it out, right? So you have to square 4/5, which means you square the top and you square the bottom. You have to square -3/5, which means you square the top and the bottom. Notice that you get +9 there, not -9, because you're squaring it, and a negative times a negative is positive. Then you have 16/25 plus 9/25 equals 1, maybe. You add those up, 25/25, and does that equal 1? Yes, it does. Right, so it's true. All right, now if you come over here to the unit circle, we should be able to actually put that point on the unit circle where it goes. Kind of just lucky here, because I made this circle. If you look, it's 5 boxes, like 1, 2, 3, 4, 5 boxes wide there. And so 4/5 is actually 4 boxes. 3/5 is actually 3 boxes. So when it says 4/5 -3/5, well, this is 4/5 right here. And negative 3/5, that's like 1, 2, 3. That'd be negative 3/5. And if you come over here, then this should be basically right there. Now it's not perfect. I just realized that this line right here is actually not lining up with the graph paper. And that's probably why my circle wasn't perfect on here. But I mean, that's pretty good, right? So what do we have? 4/5, negative 3/5. And there you go. That's a point on the unit circle. Okay, so if you are dealing with points on the unit circle, like you want to check if a point is on the unit circle, or if you want to find if a point is on a unit circle, then you're going to be using that x squared plus y squared equals 1 equation in order to do that. Okay, so that's what the unit circle is. Okay, now how are we going to do trigonometry with this? Well, here's how we do it. So, actually, no, I lied, sorry. Before we do that, while we're just talking about the unit circle, here's a really common thing that you're going to have to do. So, problem type. This is usually part of a problem and not a full problem, but I want to mention it by itself so it'll be easier for you to find. So, problem type. Given, let's see, one coordinate, x or y is what I'm talking about, x or y, for a point on a unit circle, find the other point, find the other coordinate. So an example of what that would look like would be like this. Like if I say, I could pick any number I want here that's less than 1. So like I'm gonna pick, it's so hard. What can I do? I'm gonna pick 1/3, comma, question mark. All right, so 1/3, comma, question mark is on the unit circle. And I'm going to say quadrant 1. Guess you use Roman numerals. You know, find the y coordinate basically. The y coordinate of the point. Right? So let's talk about that a little bit. So first of all, I say it's on the unit circle in quadrant 1. So let me draw. I was trying to draw a circle, and instead I drew a straight line because I don't know what a circle looks like. Okay. Move. Okay, good. All right, perfect circle. So we got x and we have y. Now, I just talked about quadrant 1 here, right? You have to remember back to a few lectures when we talked about the coordinates. So remember, quadrant 1 is this quadrant. Quadrant 2 is this quadrant. Quadrant 3 is this quadrant. And quadrant 4 is this quadrant. Okay? So when they're telling me it's in quadrant 1, and they're saying that the x value is 1/3, they're basically telling me that this is where it is, okay? And we don't know the y coordinate there, right? So that's what we're looking for. And the reason the quadrant is necessary is because there was another place where the x value was 1/3, right? Like down here, this is also 1/3 comma question mark. And you could be looking for either one of them, but they told us that we're in quadrant 1. So that means that we're looking for the one in quadrant 1, which has a positive y value. That's what I'm getting at, right? In quadrant 1, the y is positive up here, y greater than 0. Down here, y is less than 0. So that's why they tell you the quadrant, so you know whether you should be looking for a positive or a negative value. All right, so how do we do this? So the way you do this is you go to the equation of the unit circle. Go to equation of the unit circle. X squared plus y squared equals 1. Now, what you want to do with that is you want to plug in your point. Now, you have an x value, but you don't have a y value here. So you're going to leave the y as y, right? So plug in x equals 1/3, leave the y as y. So let's do that. So you're going to have 1/3 squared plus y squared equals 1. I don't know why I use that color. It's not a good color. And then once you have that, what you're going to do is you're going to simply solve that equation for y. And it's not that hard, actually. So you have 1/3 squared plus y squared equals 1. Really what this is exactly like is when you were dealing with right triangles and you were using the Pythagorean theorem to find a missing side. It's exactly like that. All right, so solve that equation for y. So I've got it right here. What do we do? Well, we should square the 1/3. So 1 squared over 3 squared plus y squared equals 1. So that's 1/9 plus y squared equals 1. We want to get the y by itself, so we should subtract that 1/9 from both sides. So minus 1/9 minus 1/9. So when you do that, you're going to get, on the left-hand side, just y squared. On the right-hand side, you have 1 minus 1/9. Now, in order to do this, you either need a calculator that can do fractions, not decimals. You can't use a calculator that does decimals on this. Otherwise, you're going to get a lot of these problems wrong because you'll be rounding when you shouldn't round. Okay? Or you can do this by hand. So if I wanted to do this by hand, I would have to get a common denominator. The common denominator is 9. So I would have to write the 1 as 9/9 minus 1/9. 9/9 minus 1/9 is 8/9. And there you go. And from there, you would take the square root of both sides. Now, you take the square root of y squared, you take the square root of 8/9, and technically there's a plus or minus there. So you get y equals plus or minus the square root. Square root 8 over square root 9, which is, well, on the bottom, the square root of 9 is 3. On the top, the square root of 8 is the square root of 8. Okay? So I'm going to stop there, and I'm just going to go back to a calculator here. So if you have a calculator that can do 1 minus 1/9, then use it. If you don't, then you're going to want to use like Wolfram Alpha or something. So you just find a site like this site, and you just do 1 minus 1/9, and it'll tell you 8/9, just like that. Okay? So you need to do it that way. So where's my notes? Where's my notes? Okay. So we're actually not quite done here. I didn't give myself quite enough room. So I have this now, right? I have y equals plus or minus square root 8 over 9. Nope. Square root 8 over 3. You can and should simplify that square root, which is something you're supposed to know from other classes coming in here. So square root of 8 is, well, 8 is 4 times 2. Oops. So you can write that as the square root of 4 times the square root of 2. And then the square root of 4 is 2, so you have plus or minus 2 square root 2 over 3. All right, so there we've done it. Now, what that's telling you is back on your unit circle that there's one point up here and there's one point down here. One of them has a y value of plus 2 square root 2 over 3, and one has a y value of minus 2 square root 2 over 3. So we want the one in quadrant 1, so the point in quadrant 1 is, well, what's the y value, or x value? Sorry, 1/3. What's the y value? Well, positive y value because we're in quadrant 1, so it should be plus 2 square root 2 over 3. And you don't need to write the plus there, but I did. And then that's your answer. Okay, and like I said, this is something that you're going to have to do in this assignment. It's definitely the hardest thing you have to do in this assignment, is finding an x or a y value that's missing. It doesn't matter which, you do it exactly the same way. All right, having done that, now we can talk about unit circle trigonometry, which is going to be easy now, so do not worry. So let's use black. I never use black. Now we can do unit circle trigonometry. Trigonometry. All right. So, of course, we're going to need a unit circle again. So let's try to come up with one. There it is. Is it? I need it to be, well, it doesn't have to be perfect, I guess. But the more perfect it is, the better. How's that? How's that not lining up? How does that even make sense? Oh, well, it doesn't matter. Oh, why? Ruined at the last second. Okay, so there's a unit circle. All right, so the first thing you need is an angle in standard position. So that's 1 minus 1. This is x squared plus y squared equals 1 because it's the unit circle. We're going to need an angle in standard position. So recall, so let theta be an angle in standard position. Now that's why we talked about this stuff in the past, so I wouldn't have to explain a lot here. So standard position, if you remember, means you have the origin as a vertex, your initial side is straight out to the right, and then your terminal side is kind of wherever. So it's just wherever you want it. So I'm gonna draw it, right here. That's fine. Okay. And in this drawing, this is my theta then. Okay. Let theta be an angle in standard position. The terminal side intersects the unit circle at a point. I'm going to call that point x comma y. That's here, right? That's the terminal side, and that's where it hits the unit circle. So this has coordinates x, y. Okay? That's your picture. Unit circle, angle. All right. With that done, then there are 6 trig functions defined now for that angle. Now we define, that's a W, we define the 6 trig functions, trigonometric functions for theta as follows. All right, here we go. So you've got your picture, and we need trig functions. So here are my trig functions. So my trig functions are, number 1, sine theta. What is it? It's just the y value. Cosine theta. What's that? It's just the x value. Okay, so like if you know the coordinates here, all you do is you just write the y value and the x value right there, and that's your sine and cosine. So it's really, really easy to do that. Now you've got a bunch of other trig functions. Tangent theta is y over x. Then you've got the other 3, which are the first 3 but upside down. So you have the secant theta, which is 1 over the cosine theta, or 1 over x. You have the cosecant of theta, put that in parentheses there, which is 1 over the sine theta, which is 1 over y. And then you've got the cotangent theta, which is 1 over the tangent, and that is x over y. All right, and that's it. This is what you need to know right here on this page. You've got the unit circle looking like a unit circle. You've got a theta somewhere in standard position, and then you have 6 trig functions. And that's it. That's your homework, right? So how do you do it? How do you do problems? There's almost no work. So if they say, terminal side of theta in standard position intersects the point. Let me pick a different point. It really doesn't want to give me a different point. Negative 3/5, comma 4/5 on the unit circle. Now, I'm realizing that the homework only asks you for one trig function. Like they'll say find the sine of theta. I'm going to say more. I'm going to say find sine theta, cosine theta, and let's do one more. Let's do the cotangent of theta. That's enough, right? You can do all 6, and there's no reason not to. But you'll understand it with this many. So we're doing sine, cosine, and theta, and cotangent. So you just say, okay, sine theta is, cosine theta is, tangent. Nope, we're doing cotangent for some reason. cotangent theta is. All right, let's work them out. So how do we do this? So we're doing sine theta. We know that sine theta is just the y value. So what's the y value right here? It's just 4/5, right? So that's it, 4/5. The cosine is the x value. So what's the x value here? Just -3/5. Just like that. And then you've got the cotangent, which you have to look up. So you look at your formulas, you find the cotangent. Cotangent is x over y. All right, so x over y. So that is -3/5 over 4/5. Okay, technically we're done, but well, no, we're not. You have to simplify this a little bit, right? So when you divide by a fraction, remember how to deal with that. Dividing by a fraction is the same thing as multiplying by the reciprocal. So you just do the reciprocal there for the bottom, and after we do that, we can see the 5's cancel. And what are we going to end up with? Looks like -3 over 4 when we're done. Okay? And there you go. And that's it, really. So if you combine this problem here with the problem that we did up here, where you had to find a missing coordinate, then that is 100% of this assignment. But let's do a problem that combines those, and then we'll be done. All right. So here is an example for you. Example. Let's see. The terminal side of angle T, they don't always use theta, sometimes they use a T, intersects the unit circle at 11/23, y. So we don't know y. What are sine t and cosine t? And I'm going to tell you t is in quadrant 1. Okay, so how do we do this? I'll draw the picture. You don't really need a picture for this at all, but there's your unit circle, right? We're in quadrant 1. 11/23, that's roughly a half, so somewhere around there. 11/23, comma, well, I don't know yet, right? So it looks like that. Then what I need to do is I need to find that missing coordinate. So you do exactly what we said you do. You start with x squared plus y squared equals 1, because this is the unit circle, right? So that's its equation. Then you plug in your point. You plug in what you know from your point. So plug in x equals 11/23, because that's what we're given. So you plug x equals 11/23 squared plus y squared equals 1. Now 11/23 squared, you need a calculator, right, for 23 squared. So just come over here, parentheses, 11 over 23 parentheses squared. 121 over 529. 529. 529. 121. Right? So you square that. You're trying to find y squared, so then you're going to solve for y. So what do? You're going to subtract the 121 over 529 from both sides, and you're going to get y squared equals 1 minus 121 over 529. Well, that's another job for a calculator. So 1 minus, for here, 1 minus that. It already says the answer, 408, but I'll press enter. 408 over 529. 408. All right, great. We need the square root now. Again, use a calculator. Square root. How do I get a square root? There's a couple ways to get a square root. You can type square root that way, SQRT. What was it? Already 408 over 529? That doesn't say 408 anyway. All right, hold on. Was that it? I need to look. Sorry. Yeah, 408 over 529. 2 square root 102 over 23. 2 square root 102. 2 square root 102 over 23. That's a 2. All right, should it be plus or minus? Now they told me that I am in quadrant 1, and that means I'm up here, and that means that it should be positive, the y coordinate. So this should actually be plus. Okay, so I have my y coordinate now. So you come down here. Now we have our point. So our point is, what was it? 11 over 23, comma, and we've got 2 square root 102 over 23. That's my point. Now from that, my angle, which I didn't even draw, but my angle is here. No, it's not. We didn't call it theta, we called it t. So my angle is t right there, and I need to find sine t and cosine t. So sine t is something, cosine t is something. Well, what are they? Well, it's easy, right? Sine t is just the y value. Cosine t is just the x value, like by definition, right? I'm not thinking about that. That's just what the formula said. That's how they are defined. And there you go. That's it. That's the problem. Okay, so that is how you do these problems. It's a nice, easy problem set. Hard part is like right here, finding the y if it's missing. Okay, so good luck with that, and I will see you in the next video.